I really want to spend time there and understanding what your thesis is, why robotics and autonomous, vehicles make sense in logistics.
Regular vehicle, ensure that vehicle can do both road and rail, not only just on clear, clean roads, but on in a multi-terrainal, type of environments. Because I want this to be for military. It's not just something that we can deploy for commercial, but with the wars that's raging right now in the world, there's rail everywhere, right? It's the quietest, it's the safest, it's the fastest way to get from point A to point B. Why not build it so that we can traverse a terrain and get on the rail and go, right? So that was the thesis behind it. And then why not throw a transformer in the mix, right? Make it cool, make it robust, make it save the world, right? And that's what Glide is all about.
And let me ask you, what do you think what's going to be the hardest challenge for you guys, and where are you spending your time right now, kind of like problem solving?
Yeah, so the hardest challenge for us, at first was adoption, right? As, how do we get onto the rail? How do we get customers in? Now it's great. We have great partners that have already onboarded. We have great partners that are coming in. Now the next challenge is let's execute and perform.
What is it that you decided to leave SpaceX? What changed?
Yeah, well, life changed for me, actually. I had my second child, my son Gideon, and needed to be home more. At SpaceX, I was doing 36-hour days. That was a normal day in logistics, department. So from going from like working underneath a brain like Elon to working underneath a military strategic fighter pilot that's running this crazy space park program for Northrop Grumman. It's like God has just continued to just like bless me with an abundance of knowledge and experience to help formulate the person that you see today.
Hey everyone, and welcome to BitBuilders, where we sit down with the greatest minds building and exploring robotics in construction and space. Before we get started though, if you're a startup founder or operator responsible for innovation in your company, or you want a deeper, more insightful look into technology in AEC, you won't want to miss our newsletter. From deep dives into particular technologies such as AI, robotics, design, software, and so on. Hot takes from investors betting big in AEC technology, and advice on building tech companies, including the stories and takeaways of the most successful AEC technology founders. Head over to www.bricks-bytes.com and sign up today to get this exclusive material straight to your inbox. And now for the episode.
Hey, Kevin.
Hey,
Welcome
Dave,
on
how you doing, brother?
Pretty good. We've talked quite a while in this last few months, and so I know a lot of things about you, but the audience doesn't know you yet. So why don't you go ahead and introduce yourself? Let's start from there.
Of course. Hey, audience, how you guys doing? I am Kevin Damoa. I'm the founder and CEO of Glide. We're on a mission to really change the way we move modalities from road to rail. A little bit about my background. I started off in the U.S. military, the U.S. Army and Air Force. Within the Army, I did 2 tours in Iraq, one in Afghanistan, and then went over to the Air Force and fought the fires that are currently blazing in L.A. From 2007 to 2018. My heart goes out to the friends, the community, the families, and the fighter fires that are on the ground right now fighting those fires out in California. So prayers on high to them. From the Air Force, I joined SpaceX. That was my first big startup. I joined the team to eventually stand up their first flight module logistics department. We specialized in transporting the rocket and all the flight module logistics equipment that went up to space. So I was one of the chief design engineers that actually supported with manufacturing and designing that apparatus and deploying it from state to state and then to launch and recovery and back again. So after that, I did some great stints with some other startups, XOS Trucks, Romeo Power, Canoe, just to name a few. And then before I started this great company, my last stint was with Harley Davidson's offshoot company, Serial One, where I supported them with their e-mobility bike. and we launched that product in 46 countries around the world. So happy to be here, brother.
No, I love it, and I guess there's so much to unpack, right?
Yes.
You can just pick a point. I'd love to understand. So you're doing. Not many people know this, but a lot of the like war fighting domain is pretty centered about logistics.
Yes.
And how do you get things in the right place for the war fighters to kind of like have everything in place, but also to maintain positions, to everything that has to do with field deployment, has a very complex logistic design behind it. And so
Yes.
you were working as a logistics manager in the Army. I'm really interested. What does that entail? You don't get to hear that often. So I feel like it could be a cool insight to pull out.
Yeah, no, totally. So in the Army, I had dual roles. So I was a Cav Scout on one hand, and I was a logistician on the other hand. So in theater, being a combat logistician, it's tricky. So you have to get, goods, whether it's, and then we see goods as people as well. So you have to get resources, food, fuel, clothes, all the material is what we call it, from place to place in a combat zone, right? So you have these long convoys of LMTVs, that is filled with these goods, and we're dodging IEDs, and we're engaging in ground fights with folks that want to pick us off, and that's a guerrilla style type conflict. Imagine a conflict like what's going on in the Ukraine right now, where you do have contested folks that and see on both sides, and they're going to try to pick off and shut off your supply chain, because that's how you choke your army. So how do you do that strategically? How do you put in a con ops for equipment, so that's going to get there to make sure your warfighter force strong, engage, and keep the morale high? It has to be very smart, right? So a lot of times we do a lot of contingency plans where we run multiple routes at the same time. It's a shell game. We may have a quarter load or a full load on some of them, just so that we can get some supplies there, because we know that some of those convoys can get hit. We're going to take some substantial losses. But the goal is always to get some sort of supplies to that ground fighter, that war fighter, so that they have, what they do. So we'll use ground or rail or air, right? But a lot of the times we air is the last resort. So that was my job in the Army.
Gotcha. It must have been very educational for doing stuff in the hardest conditions.
Yes.
I guess. That's probably the biggest learning for you. Like, what did you take with you? Why? There's a lot of people that used to work in the military that then transitioned to SpaceX. I mean, the simplistic way to think about it is like, national security clearance, or like security clearance are some of the answer.
Mm-hmm.
But then also, SpaceX was fighting its own war, which is basically getting everything ready so fast and refurbished so fast.
Mm-hmm.
So what did you take with you from your logistics job in the Army? It was just like serving to SpaceX. What did it translate? And then also, what is even a logistics module management role? Explain us that.
Yeah, no, of course. Yeah, so the answer to your question, when I joined SpaceX, I had both Army and Air Force under my belt at that time. 6 years Army, and by the time I joined SpaceX, I was in the Air Force for 2 years. So I got that ground troop experience to that aerial experience. So I had that that complete dimensional experience from a logistical perspective. For a warfighter, that can be applied to an operation like SpaceX. So I joined SpaceX when we were scrappy, right? Where we really didn't have a lot of money. We didn't have a lot of money. We didn't have a lot of equipment. But what we had is a lot of drive, right? And we knew that, like in the military, when you have a mission that is timely, we had a mission that was timely. So you put in scrappy ideas that that are robust. You put together applications with contingency, knowing that there's no way that you can fail. And that's the same attitude that was there when I got there, because there was a lot of military folks already there, like, as you stated. But that was the attitude that I onboarded my staff with as well. I worked with a gentleman named Alan Merrick, never served in the military, but you would think this dude was a staff sergeant to the core. He was a test guy. A lot of test guys are like military guys. And him and I ran an operation like we were on night missions in the military every single day.
Hey listeners, I want to take a quick break to remind you about the Bricks and Bytes newsletter. If you're interested in learning about the technology shaping the future of construction, you won't want to miss the valuable insights we share each week. To get this exclusive content delivered straight to your inbox, head over to www.bricks-bytes.com and sign up today. Link is in the show notes. Back to the show.
Because we know that with the rocket, we only get one, right? Especially if we didn't have a lot of money. So if something happened to that flight module that we're transporting, then the mission's done, right? The whole entire company entrusted a multi-million-dollar asset that was irreplaceable with our team. Very small team. It was Alan and I, and then we hired 2 other technicians, and we were the chase crew, right? We were the design crew. We were the planning and operational crew for the first 5, 6, 7, 8, 9, 10 rockets that came out of SpaceX. We packed it up, we put it onto the apparatus that we designed and deployed. We went from California to Mexico, let that test at ATP. I'm sorry, not Mexico, McGregor, Texas. We let that test at ATP. Once it was done after 2-3 months, we either took it to Cape Canaveral with that same exact team or to Vandenberg, and it went up. When it was time for us to recover it, we were there in the ports, and the port of where was San Pedro. We were there at the ports to recover debris, right? We were there at the ports to recover the capsule alongside NASA's ground support team. So we were always hands-on. We weren't just engineering managers or operational managers. We were there in place to ensure that the mission got done every single time, and that's equivalent to the military. Once we step on boots on ground, we don't walk away from the mission just because it's whatever. We are there until the mission is done. And the time that we put our feet up is when the mission is absolutely completed and we've been debriefed. And it was no different at SpaceX. So what flight modules is any module that is intended for space that is going to go up and re-land.
So awesome that you had that experience, and it made you understand also, commercially, when you're not only defending your country, now you're basically defending a commercial space mission, which honestly is, to me, is, just as cool.
Oh yeah. But for me, it's one and the same, right? I mean, what like SpaceX was doing, like the EELV mission for the Air Force, right? For the military satellites. So at that juncture, it became the same, right? It was no difference. I was in the Air Force, actually supported them with their EELV certification acquisition. I was on that team that helped close down that contract, sorry, not the contract, but that, it's contract, right? Is
collaboration. Yeah.
Collaboration. Yeah. Yeah. I was on the team that helped get that certification for SpaceX to win that program. So that felt great. And I was still in uniform. So that was really cool.
So basically, for the benefit of the audience, in what was it, 2014, 2013?
Yep.
SpaceX was launching a bunch of Air Force satellites, which obviously were super sensitive national security payloads, and they obviously had to get certification for them.
Mm-hmm.
They're not the usual kind of like, highway traveling certification.
No, hell no.
No, there's quite a bit of logistics and operations that are behind that. That's really hard to get. And you got to ensure that everything is safe, secure, alongside, and also that that your payload's gonna get there with a decent probability, right?
Oh yeah.
And so that must have been a really complicated process. And
it really was. It really was. Because I mean, like, just like you said it, you have to go through every single corner of the company to make sure that you have robust processes in place to ensure it goes into a vehicle that has 100% guarantee that payload will get there, because that payload is for the warfighter. Right. That's all of our military capabilities. There's, billions of dollars that goes into, a program like that. And if it blows up, I mean, it's a lot of wasted time and a lot of risk in place. So, great points.
And then what is it that you decided to leave SpaceX? What changed?
Yeah, well, life changed for me, actually. I had my second child, my son Gideon, and needed to be home more. At SpaceX, I was doing 36-hour days. That was a normal day in logistics department. So I needed an easier route. So I went over to Legacy Aerospace. I went to Northrop Grumman and jumped on the F-35 fighter jet program. Started off there as a weapon bay door engineer, and then eventually transitioned over to program management and led their sustainment team, for the product, and did that for a year and a half. Got a great mentor in Corey Moore, who was the leader of Space Park, at the time, that really injected everything that he knew into me. He was a Northrop Grumman for 22 years, ex fighter jet pilot for the Navy. So super bad dude, so it was an absolute gift. So from going from like working underneath a brain like Elon to working underneath, a military strategic, fighter pilot that's running this crazy, space park program for Northrop Grumman, it's like, God has just continued to just like bless me with an abundance of knowledge and experience to, help formulate the person that you see today.
I love it. And all of these learnings, I mean, I can see a person like yeah, and I've gotten to know you, and I know the grit that you put in things, and the strength.
Thank you.
And I feel like if I knew you back then, it would have been a very logical conclusion that you would have started your own thing. And I really want to spend time there and understanding what your thesis is, why robotics and autonomous, vehicles make sense in logistics. Where do they make sense? I have so many questions, but I'll actually let you start with like the Nexus story.
Yeah.
When is it that you got together with your co-founder or just alone and said, hey, I should actually start my own thing and this should be it? So what was the idea, Mace?
Yeah, no, totally. So the genesis of it all, it was 2022 in the fall. My wife and I decided to give birth to our son at home. It's our last child. We have 4, in our living room up in Yosemite National Park. And after he was born, I just had this catalyst, this idea of, what am I doing? Right. I went from rockets to bicycles. Right. At that time, 2022, we still were dealing with all of the port issues. You started to see the cracks in the foundation of the infrastructure here in America. And we were losing the manufacturing fight. We're losing, our ability to actually industrialize, for ourselves. We're outsourcing everything. And then when we attempted to, really put a strain on, what we currently had, we were breaking. We're at the point now where we're shattered. But I knew at that point, hey, we're going to eventually shatter. And I don't know how fast, and I don't know how hard. So what I did was I looked at every single modality, because I've worked in space, air, ocean, road, and rail throughout my entire career. At that point, I was doing logistics for about 20 years. I've seen and touched everything that you can think of, from e-mobility to regular military assets to, regular cars, everyththing that moved, I've touched at that point. So it's no different. So I said, well, do I want to do a rocket? They said, no, I'm not, I'm not that guy. Do I want to do a plane? I'm not that guy either. But that's cool. Maybe I can do it some other way. I was working with hydroplane. We were doing hydrogen-powered airplanes for the Air Force and the Navy. I said, but that's not a way to solve this infrastructure problem. So my next thing was to look at road and rail. And I was like, well, they're both on the ground, right? And where are our pinch points? Breaking it down to first principles. Where are our pinch points, and why do we have those pinch points? So it was road and rail. The pinch point was to transload, right? An area that is very, very labor intensive, is very unsafe, and is extremely costly, not only from a time perspective, but from a monetary perspective as well. And how can I make it better? By throwing in emerging technologies, robotics, AI, electrification, not just electrification, alternative energy solutions throughout it all, synthetic fuels, hydrogen, possibly nuclear, batteries, everything else. How can I improve this? By first looking at first principles, design a vehicle that can traverse both road and rail, essentially eliminate that transload process that is, really hampering rail's ability to have, assets being deployed on it, and go with it. So that's when Glide was born, right? Overlay a regular vehicle, ensure that that vehicle can do both road and rail, not only just on clear, clean roads, but on in a multi-terrainal, type of environments. Because I want this to be for military. It's not just something that we can deploy for commercial, but with the wars that's raging right now in the world, there's rail everywhere, right? It's the quietest, it's the safest, it's the fastest way to get from point A to point B. Why not build it so that we can traverse a terrain and get on the rail and go, right? So that was the thesis behind it. And then why not throw a transformer in the mix, right? Make it cool, make it robust, make it save the world, right? And that's what Glide is all about.
I love it. And so your thesis was really first principles on like, where do we need enhanced mobility? And we need it across these two domains. Yes. Wheel on the ground and rail. What is it so what's the status of the American rail infrastructure that you think it's, ripe for innovation and rebuilding if it needs that? And where do you see those choke points the most?
Yeah, so rail in America is old, right? It's old. It doesn't really innovate. I mean, there's folks that are looking to push the needle forward in innovation. Parallel systems, Intermodal, just to name a few. And there's electric trains and there's hydrogen powered trains, and they've done great things with positive traction control and shunting and electric, parking. But it's not solving the problem for transferring goods from road to rail, right? Road has an enormous amount of congestion, and potholes and everything else, and it's not going away, right? The more people that you have on roads, and unless you have a private road dedicated to freight, you're never going to improve that. If you don't solve for the transload, for increasing the accessibility onto that rail, it'll never work. I mean, it doesn't matter what kind of futuristic train you come about, it's just another train, right? Until you solve for that middle step, going back to Elon's term, local maxima, until you solve for that middle step, you're still just adding to more problems to the equation, right? If you still need a transload, you're still putting more time and cost to your logistics process, and increasing inflation, by doing that. So if you streamline the complexities of that entire process, looking at the amount of touches that a good has on one modality, then you solve for the entire equation just from a vehicle perspective. But there's more, right? The next level of detail is, your freight brokerage. How do you improve that? How do you improve your load optimization? How do you improve your routing for things? How do you improve your availability of these vehicles? This is the next tier that Glide goes into. So our first tier is our hardware, the amazing gliders that we're displaying. The next tier is Escher 1.6, which is our software that does brokerage, that does load optimization, that does payment processing for our customer, that does track and trace, that does positive traction control for our customers. That's that next piece. And then the last level is actual workers, right? It's upskilling those folks, providing them with next level jobs in robotics and automation, so that they can not, do port strikes for semi-automation and automation that is going to actually save their lives and improve their quality of life. We offer a product for our LMS, our learning management system, that does exactly that. So when we talk about Glide, it's all three, and then robotics and automation is throughout each one of those steps. It's either teaching them how to do it, monitoring it within our software, or actually deploying it in our actual robot, and that pulls it all together.
Where do you see these units mostly, right? Where's the best spot for them? Is it port terminals where a lot of goods are moved around? Is it those big nodes where basically rail stops, trucks come? So where do you see them?
Yeah, I see them everywhere. When I first started with Glide, when I first built Glide, and I saw them at the ports, because ports need a lot of help. And then when I started to zoom out, I saw pre and post processing for for lumber and raw materials and mining and trash and waste, where they cut down the trees and then they have to process and then they go from road to rail, do it all. So I was like, we can put this almost everywhere. And then the last piece where I recently started to zoom in and out at is our borders, right? Our borders have rail and road along it. What about contested logistics where we have some border protection for an asset like a glider that can traverse and move, modalities, people, or monitor it, just on its own. So Glide has a position everywhere in the world, even in theater, for real contested logistics. So,
Gotcha. So, what? Tell us a bit for the nerds, right? Tell us. I mean, this is honestly.
I'm a nerd, man. I'm a nerd. Proud
same,
nerd.
like same. That's a podcast that proudly leans toward the nerd.
Yes.
And I really wanted to try to understand. Let's dive into the vehicle. Obviously, what you can say from a high level perspective. How have you thought of it? Right? How do you come up with it? How are you designing it? What do you envision its evolutions to be?
Yes. Yeah. So the glider will have multiple evolutions, given, what we're seeing in the market, manned operations that still need to be in place. And we want to ensure that humans are in the loop. I think that's one of our core pieces. So our design is human centric. And what we want to do is not reinvent the wheel. There's plenty of e-axles, there's plenty of regular axles in the world. We're not going to design, our own axles, right? That doesn't make sense. So, integrating commercial off-the-shelf solutions, for road and rail base, right? Rail has come a long ways in its bogie design. Siemens, Kawasaki has done really great at lightening up the bogie design and making it more robust so it can be on lightweight frames, but still do heavy duty jobs. So, taking those commercial off-the-shelf, parts, integrating into a vehicle that's proprietary to us via, great chassis design, lightening it up, ensuring that suspension can do both static and, dynamic loading. And then, deploying it, underneath, an alternative energy solution is how we've gone about looking at it. And then you overlay that with sensor fusion, so that we can, not only drive it safely, but ensure it's in an environment that's safe. And then you overlay that with the ability to do geospatial mapping, road inspection, rail inspection to protect not only the assets that we're supporting, but the glider itself. That makes the perfect robot, right? And that's what we're doing, right? Optimus Prime had sensors all over him, right? He just didn't have two pair of eyes. He had them everywhere, right? So this is a walking, talking, rail traveling Optimus Prime.
It's awesome because I realized literally this like 6 months, maybe 4 months ago, reading some thread on Twitter. Yes, Optimus Prime doesn't have eyes. Like, what?
He's got sensors.
Makes perfect sense.
Yes.
So one thing I'll say is, like, for example, what I'm seeing very often is that the first application for autonomous driving is likely going to be inside the yard. And the reason behind that is obviously you don't have a lot of edge cases. You have less regulations that are telling you, hey, don't go, just don't go hit random cars when you encounter a edge case and you just can't handle it. So, first of all, I love the thesis on where autonomous driver will start. And then I also love that what you're doing is basically moving cargo, initially at least, moving cargo in places where moving cargo is extremely manual. There's actually either a truck that is driving a trailer somewhere, or literally guys with, some kind of pusher. So, what do you envision? What are the industries that you, for whatever you can give away, right? What are the industries that are more hungry for this solution? Where should we imagine this?
Yes. Yeah. So I mean, I can go directly to our first partnerships, right, out in Washington and Oregon. So Taylor Transport, they run a mining and drayage, operation, and they move waste for waste connections as well. So that's our first use case. Taylor Transport, they own their own rail line, and they work in conjunction with PVJR, who we have another partnership agreement with as well, Portland Vancouver Junction Railroad. They have 33 miles of rail that they operate on, that we have full access to. And our first mission will be to, move rock that's processed from the mountain and then broken up and then, made into, other materials such as glass, smaller rock, and sand as a piece of their operation. And then we'll be moving waste for waste connections. So that's our first mission that we'll do out of those guys. In addition, we have a partnership agreement with the Port of Woodland, and the Port of Woodland moves those two commodities as well on their site, and they do a little bit of drayage for containers, small volume. So our first steps will be rock within mining, waste, and then some container operations as well as a first step. And the great thing is, it's all private property, all private road, all private rail, to really test out the use case, ensure it's safe for everybody. And then as we push the limits, we can start to demonstrate it on more public land or public roads, and rail is all private. So more class one interchange later on down the road as we step into our phase 2.
Rail is all private founders, so if you want to test this stuff, it's actually a perfect place.
It is. It is.
Wow, I have so many questions. I mean, one that I have is like, how do you charge for this? Meaning, how do you back out the right price? Because me as a profane, I haven't started building a startup in rail and road.
Mhm.
What I can imagine is obviously you're doing some improvements on safety,
Yes.
because there's more comprehensive sensors that are working better than probably the average train driver, which, by the way, I'm sure it's a class in which we don't get a lot of new labor.
Mhm.
But how do you charge? How does the business model work?
No, that's a great question. So we're mobility as a service. We're actually building these for ourselves. We're owner operators for the product, and we do that so that we can control the life of our vehicles, for one. The second is we can provide them with the level of service that we want for ourselves, which is superior to what's out there. A lot of suppliers or manufacturers, they make a great product, they put it in the customer's hands, and the customer has to figure it out. We don't want that. We want to solve a real problem, both operationally and from a capital expense standpoint for these customers. We're not only, improving the way that they move, but we're cutting out a lot of the capital expenses that are going to naturally phase out over time because forklifts are aging out. Cranes are going to age out as well, along with trucks and trains and carts and everything along that supply line that we're looking to solve. In addition, there's labor shortages, right? So by hiring us, we're there to offset the labor shortage that you currently are facing. Not only now, but a couple of years from now, where the numbers hit in the 100,000s, and by 2030 for all supply chain type jobs. So how do we price that out? Well, we price it out by knowing what our capabilities are, but at the same time, right sizing it so that we can, have a direct impact on the consumer's bottom line. Because, as I stated before, some of the operational margin or the hits, the inefficiencies within logistics contribute directly to the increased price of eggs and everything else. Because those landed costs lost have to go somewhere, right? When a customer says, hey, I spent 70% more on logistics than I thought I was going to, they're not eating that cost. They're putting that cost back into the margin of the product that they're selling to us. So we've adjusted our price to try to right size the economy for what we can control. And for the rest of it, we hope we influence the rest to do the same.
So you're picking an outcome as a service type of model where you're basically moving stuff. And
Yeah, exactly.
Simply doing it cheaper. In the end, you're just simply, aspiring to at scale move this cheaper than anyone else, because you got technology that does it for itself. Okay.
Yep. Exactly.
And let me ask you, what do you think it's the what's going to be the hardest challenge for you guys, and where are you spending your time right now? Kind of like problem solving.
Yeah. So the hardest challenge for us, at first was adoption, right? Is, how do we get onto the rail? How do we get customers in? Now it's great. We have, great partners that have already onboarded. We have great partners that are coming in. Now the next challenge is let's execute and perform. So we have some pilot programs that are coming up this year, where we're going to really test our mettle, to see if our execution works. And then we lead up to our next hurdle, which is regulation. Once we get into our phase 2, that's when we're going to be facing regulation. And what we hope is everything that all the road guys are doing, for an autonomous, vehicle perspective, will translate over to rail, and we'll be allowed on rail, even more. For the class ones, I would say regional rail is a bit easier, because it's more localized. But, our next challenge will be those class ones to get approval from the FRA to do the things we want to do. And we see what the road guys are doing. That shouldn't be much of a challenge then. One would hope.
I love it. And so, how do you build a team for this? Who are you picking? Because I think a lot of the founders that at least I speak to, the most challenging problems tend to have the biggest talent pool drawn to it.
Yeah.
They're just cool stuff to do. And cool stuff to do actually attracts good talent, and good talent makes cool stuff happen. Right.
Yeah.
So that's pretty much the cycle. But I want to try to understand from your perspective, you're running a deep tech company that it's trying to solve a problem that is very niche yet very impactful.
Yes.
And as it's early stages, how do you go about scouting for good talent? I'm sure your network is huge given what you've done, but like, what do you look for?
Yeah, I look for tenacity. I look for, grit, and a huge imagination. And, above that all, the two biggest attributes I look for is integrity, and a undying pursuit to solve a real problem, right? You had to have a passion for the people, for the community that we're looking to solve this problem for. What's the sense in doing cool stuff just to do cool stuff, right? You want to solve a problem and save a person's life, right? You want to look at a mission that's bigger than you, that's going to echo for generations and generations. And that's what I look for in founders, or just employees, period. Like my co-founder, Matt Mueller, for example, he ran, manufacturing at SpaceX, worked in Falcon 9, Dragon, Starlink, Starship, and then went on to, work at other startups like Adrian and Antora and Ship4, and Imperium, bigger companies now that are really doing dope things. But their missions are very significant, and their CEOs really believe in the mission that is upon them. I picked him as our COO, because he has every single one of those attributes, and he can do other cool stuff. He can bring stuff to the table, that I may not have imagined out, believe it or not. That's what I look for folks, and we've been blessed enough, for one, to have we've had a great network from the companies that I worked at. And then number two, we have a mission that folks are like, dude, I want to be on something like that because of what it stands for. We're not just, moving commodities and stuff like that and, going from road to rail. We're targeting like marginalized communities that within the United States within the United States look at as low hanging fruit. The folks that folks don't think about, the logistics workers that do all the packing and the shipping and work long hours so that we can get, our Amazon packages at our doors, that are paid the least, that work the most, but have the biggest hearts for what they do. We target those folks to improve their livelihood as well. And it's a mission not a lot of folks think about. But if you look within your family, there's a lot of those folks within your family that work, those jobs. So, when folks pull that back, they're like, dude, I'm actually going to help out my uncle or my mom or my cousin or my, grandkids or my whatever down the road by just being on this mission. Yeah, it's not going to outer space, but we're solving for the folks that are overlooked daily, that do the most for us every single day. So
what is the outlook there? What do you think is socially and systematically wrong in the United States with all the jobs that have to do with moving goods and in general, those that are actually not getting a lot of net new labor just because of this reason, because they're not very compelling. I think that the port strikes were a big part of this, and I mean, there was some political motivation, but I want to try to understand what's the social motivation behind it.
yeah, I mean, like the geopolitical, issues in the United States go back a long ways. I mean, rail was built, by, the transcontinental railroad, was built by, slaves and, Chinese workers that were, brought over to get it done. I mean, there's a lot of injustices here in America, and you're starting to see it more with port strikes. And with those injustices, a lot of ignorance as well. The port strikes are a direct result of academics not being injected into these neighborhoods, these border communities that, make up all the port workers. 90% of the ILA live by the port, right? It's a significant number. And they're not educated enough to know that semi-automation and automation is going to improve their jobs. If you take a vast comparison, and I'm going to give you two examples. Port of Rotterdam, who, the Netherlands takes care of all their people, no matter what, race, color, creed, sex, gender choice, whatever it may be, they take care of their people, right? It's the most efficient port in the world. It does almost triple the capacity of our most efficient port here in America. Why? Because they care about the people. They care about their workers. I can go to an alternate, and dare I not say Shanghai, right? China, same thing, right? You can say, hey, Chinese don't care about their people. They darn sure do, right? They're automating and adopting automation within their ports because they care about their people. They care about the velocity of goods that goes, through. They know they have to take care of their people in order for, their country to function the way it needs to be. Within the United States, we're like, hey, you know what? These people have been, do the ringer for years. How much more can they take? They can absolutely take more. Now the top is being blown off of that thesis, and folks are fighting back, right? And are they fighting back for the right reasons? I think there's a better way to fight. I think that as a nation, what we should do is exactly what Glide's trying to do: is provide them with the ammunition that they need to be successful, the education, the right tools, right? Robotics, automation, AI, the right skills in order to improve their quality of life, raise up the value of their neighborhoods, provide them with real generational wealth that comes in the form of knowledge, so that they can be like everybody else. There's no reason why our port adjacent communities can't be middle class communities, right? Nice communities where folks are like, I love living here. I want to inject more into these communities, and I want to bolster this port up, right? Because this is a big hub that's a portal to my nation being, successful. But we have the opposite, where we abuse all the ports. Oakland, Long Beach, Tampa, Jacksonville. I mean, all of these are surrounded by ghettos, right? And there's no reason why, right? We can directly influence that, and that's what we want to help do.
I love the mission. I think it makes a ton of sense in the context of basically a feature and a bug of capitalism is when something is not working, it doesn't get enough revenue, then I have to cut on the cost. And unfortunately, what you find is when there's a lot of capital already injected, what you cut on is labor. And you cut on the not only the salary in itself, which is not the point. It's more likely in the surrounding conditions that have to do with working conditions, time, effort that these people have to put when basically technology can bridge the gap much easier in a much easier way. How do you think of what else can with that to do with automation and technology can change this in these big nodes? So I think port automation with robotics is a huge topic. and it's not only related to kind of like on the ground and rail logistics, which is the piece that you're building. What have you seen that we will probably see? If at least if we have, at least we have administrators that care about the future. If we are lucky enough to have that, what we will see in our ports and in our big logistics nodes in the country.
Yeah. So I mean, all material conveyance movers, right, should be all automated. I mean, if you look at Rotterdam, you have a robot that drives around and picks up the cranes, and I mean the crane picks up the containers and drops them off on the different modalities, fully automated. You have a person behind the desk that monitors it all and is able to step in, right? Or you have a whole, in China they have a whole room full of folks that are looking at every aspect of the port, of their fully automated port. So I think every piece that's mechanical will be automated. And I feel it'll get to the point where you'll have, accelerometers. Well, you'll know the temperature, the mass control, where you can really optimize the way that, the goods are moving. I think it's going to get to a point where, there'll be, in-ground, kinetic chargers, where these vehicles can run along the ground and be recharged as it goes down. Will be the next phase in robotics and AI for completely optimizing the way things go to the way that the Panama Canal functions, right? That's an automated process now, and they push your congestion through pretty quickly if the water levels are right. I feel ports can get to that point, and will get to that point once automation is let in.
And not many people know this, but or maybe I didn't, but basically been studying a bit port automation a few months ago for looking at a company that that basically I was assessing, and I realized every port that gets built today, it's either semi-automated or automated, but very few ports get built today. Most ports have already been built. Now, the automated ports are very efficient. They're not so much more efficient than the non-automated ports, but they're much leaner, safer. Basically, people don't get hurt in them. I didn't know that portsmen are basically in the category together with roofers that gets hurt the most. And so that was the biggest reveal for me. It was like, okay, it's really hard to inject automation because these are such big pieces of infrastructure. It's actually hard to build them anew today.
Yeah.
But if we were building today our port infrastructure, our land to ocean interface, we would actually build them completely differently.
Yes.
But the reinvestment, like always, the brownfield opportunities are actually the hardest to capture. There's downtime. There's, who gets to carry the cost. And then you have the terminal operators division from the port. They're two different entities, two different businesses. It's really complicated to streamline this. What do you think? Where do you think in America we have the best and kind of like most forward-looking piece of infrastructure that we should kind of like look at and emulate?
Yeah, I think if you look at passenger train in areas, I think that's the most innovative I guess mass movement that we have here in America. The freight side is slow, but there's a lot of companies like Brightline, for example, that are doing mass electric train or whatever transit train improvements, and that's it. On the freight side, there's none. On the freight side, believe it or not, the last innovation that we've adopted nationally is containerization. That was 75 years ago.
By the way, you were mentioning the crane. I knew the name. I knew the specific name that moves containers at the ports.
Yeah.
It was invented in Rotterdam.
It's been in Rotterdam, yes.
And actually, I used to live in Rotterdam. I lived in Rotterdam for 2 years, and basically there's a monument of the first ever crane to move containers. they had actually a smaller standard measure back then that is placed on the basically on the coastline in Rotterdam, where you can just walk and eat ice cream, and then you're basically looking at this giant crane.
Yeah,
There's a monument to the Dutch invention.
that's crazy.
Moving. Yeah, it was the beginning of the industry in Rotterdam. And if you actually go and I used to live in a skyscraper in Rotterdam. It was a random arrangement. It cost the same as a student accommodation for some random reason. And from the 30th floor, I could actually see the port.
Oh wow!
And the port was, I guess if we could check the area, but eyeballing it at least twice as big as the city.
Wow! Wow!
It's like
wow!
Humongous piece of infrastructure, and a friend of mine told me this joke is like, I made the mistake. I wanted to visit the ports. I made the mistake of asking someone, "Hey, can you take me to do a tour of the port?" And I was like, "Right, like where? Like where should I take?
What part of it?
Yeah, which one of the 117 entrances should we take?" That's what he. I'm like, I don't know.
Yes.
So just a testament to how big that infrastructure is.
Oh yeah.
So you want to work at the conjunction. So Glide wants to work at the conjunction between, basically, in this case, at the beginning, if you're working in ports, ocean freight, and the rail that comes there and moves most goods around the country, right? What's the initial feeling from these customers? Like, how have they taken the opportunity to kind of like, step up, embrace automation, and see their goods move around automatically one day looking from a window?
Oh no, totally. Well, I mean, when we first joined up with these customers, Taylor Transport, PBJR, and Port of Woodland, they're like, dude, this is so exciting because we get to cut out the transload, right? The transload is like a bad word, in the freight movement community, right? Because it's so labor intensive.
What is transload? Explain us transload.
Yeah, no, of course. So a transload is when you take a commodity, right? So say you, I'm gonna walk through a port operation. So a port operation, the boat pulls up, a crane unloads the boat, right? And it puts it into a marshaling queue, right? Until it's time to go. Cause it's never, you go from boat to go, it's always, you have steps in between. So it puts into a queue. Once the container is up for queue, then another, forklift or crane picks it up and puts it onto a ground-based, truck. Right? A yard marshaling truck. We call it a hostler. So a hostler moves it over to where it's going to get positioned to the rail. Then a forklift or a crane to come and pick it up and then place it onto the train track. That process is called the transload. That's only one step though, because that's your end step. On the other end, the train, probably takes about 2 weeks to depart because you need 2 miles to meet the units of economics. The train departs. And then on the other side, the transload, then it's the process in reverse, right? So you'll have the forklift or crane pick it up, put it onto another hostler or a middle mile truck, and then it'll go the other distance. And it may do that a couple times, depending on how far the distance is and what route your brokerage sets for you. But that process alone costs anywhere from $800 to $2,500 each time that happens. And depending on what the economies of scale is, and that's your terminal handling charges and the merge and everything else that's baked into that cost.
Okay. You were talking about the unit economics that needs to be cleared for the transload to make sense. Can you expand more on that?
For the train to the takeoff, it makes sense. So transload, they people typically do it because they want to expedite their route, right? If not, then they say, okay, I'm going to put it on my regular train. The train is going to take its time. It's anywhere, if you ship something from Tacoma, Chicago, a regular train will take you 22 days or more, right? Without the transload. If you did a transload, it'll be 9 to 12 days for the ticket. So you can subtract, about 10 days if you included the transload inside of it. A train typically won't take off until it's about 2 miles long, because the train is so efficient. It needs to have that amount of cars in order for that rail to make any sort of profit.
I had no idea. I never thought about this.
Yeah.
So does that mean that the efficiency of the transload operation are basically very directly related to when you get your goods, even if you're simply transporting by a few hundred meters from like, the quay to the quay area to the train, that where your goods spends a ton of its time?
Oh yeah. It spends a ton of this time on a train. The other piece that's impacted. So a lot of folks just say, you know what, screw it, screw the rail, I'm gonna go truck. But with trucks, the issue is congestion, right? So congestion has an impact on it, and then the rising fuel costs and the rising driver costs is the reason why folks are like, I'm just gonna put it onto a train and let it go, that route, right? But then they have to pay the transload, right? So it's like you pay for this or you pay for that. I was in a conversation with Waste Connections, and I asked them just very pointedly, hey, why don't you move more trash via train? Because you put so many truckloads on the road. And they're like, I can't afford to transload. Right?
Incredible.
I mean, it's like, dude, I was like, it's a faster route via train. They're like, yeah, but we'll lose every single piece of our margin, on just the transload.
Seems like a great opportunity to tackle, doesn't it?
Totally.
I love it. I think this crash course on port operation is going to be super interesting. Again, for the nerds, thank you for making this podcast heard. But I have a last question before my last question.
Okay, cool. And the preemptive question, the pre-question to the last.
Exactly. My question is, where do you see Glide in 10 years? Where do you want to be, right? So what's your North Star? You know all of these problems. You've found people and design partners that really understand them together with you and are willing to support you, seeing this vision through. You're building a great team. I've seen your team. It's incredible. I really would tell people to check you out on LinkedIn because you won't believe it. And then you seem to have these pieces. Where do you want to layer them up until? Like, where do you want to see Glide in 10 years?
Yeah, in 10 years, our moonshot is to be on the moon, right? Moving cargo on the moon, from that rail that DARPA's looking to put on it, right? That's our moonshot. If we pull back to Earth, Glide is everywhere, right? We are moving. We've helped to fix that. We've done our part to help fix the infrastructure issues that we have here in America, and America is able to reindustrialize the way it is intended to do, right? And we are another industrial giant because we cleared out our ability to ship things. We now have we have less road congestion, we have more rail utilization, and rail utilization in America is up to 95%. We want to use 5% margin out there instead of the low numbers that it is now. We're flowing. We're in ports. We're helping out with industrial parks and other consumer places, and we've helped this secure our borders as well, not just in the United States, but supporting Mexico and Canada and all of our other partners as well. And we have other footprints around the world. Is where I see us in 10 years.
I love it. I mean, it's a mission worth of your background and what you've done.
Thank you.
I think you made it a living to do hard things. Which is the entire point of BitBuilders is like, we want to talk to people that do hard things, that build hard things.
Yeah.
I love it.
Thank you.
My last question now that comes is, I think you'll have something interesting to say here. What is your advice? I always have the conversations like that.
Mm-hmm.
What is your advice to people that are building hard things, maybe for the first time, right? They're building a startup in a really classically hard industry to build in, something that has a lot of incumbents. I'm talking about rail and road, like something that has a lot of incumbents. It's really hard to innovate, long sales cycles. You have to build hardware. You have to convince investors. What's your advice to them?
Yeah, I mean, first and foremost, believe in it all, right? I mean, just don't do it because you think it looks fun. You know, really really look to solve the problem and know that you're the person to solve the problem. That's the first and foremost, and never doubt that you're the person to solve that problem. Think the problem all the way through and talk to your customers about their problem first to buy down any of the assumptions that you have about the problem. And then talk to their customers about their problems as well. Go as many layers deep as you can to really realize what the problem is. And then, the last piece is spend time in the problem. I mean, if you can sit down with the customers, if you can, not, as a startup founder, you probably can't be a customer because you're broke for a majority of the time. But be in the problem, right? Be around the community that's impacted by this problem. And once you're locked in and you can feel what the problem is, you'll be able to solve it. And while you're solving it, don't give up, right? And it's deep tech and it's a tough problem to solve for a reason. If it wasn't, then it'll already be solved. No matter how smart you are, there's a lot of smarter people and there's a lot more money in the world where folks will come together and do it. And they still haven't solved it. So the problem is yours to solve. Believe in that, trust in that, never give up. And there's folks like Gabe that will believe in you if you just, stick around and keep inspiring. So, I think the power of belief is the strongest thing in this game. It's not about, how much money that you can get right away or what cool of a program that you can put together. Cause as you know, it can get bubbled out and gone in a second. You've seen it with climate change, electrification, robotics. I mean, it's always a bubble, right? You want to push through the bubble because the problem that you're solving is not in a bubble, right? It's reality. So that's the advice that I would give.
Thanks, Kevin.
You're welcome.
Really, really cool to have you on. Thank you so much for your time.
Yeah,
I know we'll speak soon.
Yes, of course. We always do, man.
All right, man. Have a good day ahead and see you soon for part 2.
See you soon, brother.